All right. So we're looking here at Newton's second law problems. All right. We've dealt with some free body diagrams before, which is a box that just shows all of our different forces on it. And then from here, what we're going to wind up doing is we're going to wind up solving for any of the missing variables that they ask and giving the proper units and everything else that we may need. So there are two things that I'm going to ask you guys for from this one. I want you guys also to please write this in. Guys, everybody? Okay. I want you guys to also find the mass. So we had just done this. You know that weight, Fg, is equal to mass times gravity. We're just using 10 for our gravity. So literally, if you're given Fg, God bless you, just divide by 10. Just divide by 10. So this one, if I divide this by 10, what is 100 divided by 10, guys? 10. That would be 10 kilograms for the mass of that one. 150 divided by 10. God bless you. 15 kilograms. That would be what the M is, our mass. The next one, 600 divided by 10. 60 kg as our mass. $15 kilograms equals mass. 20 divided by 10, you're going to get, or 200 divided by 10, you're going to get 20 kilograms for the mass. And 200 divided by 10, again, also 20 kilograms for the mass. So you have these pieces of information here already kind of given to us. We had to do just a very, very simple division problem. Okay, the next step they wanted us to do is find the magnitude and direction of the net force. The magnitude is literally just means the number. So we're going to give us the number, the unit, and the direction. All right, so guys, let's take a look at this first one here. What is the net force on this guy? All right, well, what do we do if they're in the same direction? They're in the same direction. Okay, we're going to add them. If they're in the opposite direction, we are going to subtract them. So if you have 100 up and 100 down, are those balanced? So what I'm going to do is I'm going to put a little equal sign right there. So I know that they're good. They're not bothering me. They're not going to really take part in the net force because we're good. We have 20 to the right and 20 to the left. Are those balanced? Yeah. So my left and my right are balanced. So is everything balanced? Yeah, so I don't need to add or subtract anything. So the F net is equal to 0. 0 newtons. Moving on to the next one.
And that would be the answer?
Yeah. So that would be your net force because everything, right, all the forces that were drawn on here, all the force vectors, they balance each other out. But on this one, they have a tension force of 400 and a weight of 150. So these two are in opposite directions. So if they're in opposite directions, we're going to subtract 400 minus 150. It's going to be what, guys? Good. So the net force would equal 250 newtons. And in what direction? It would be up because the direction is going to go in the same direction of whoever was the larger force to begin with. All right.
You have to put up.
Correct. To get the full thing.
So for the first one, do you put balance?
You can just put F net as 0. If it's 0, then you don't need a direction. That's a good question. Very good question. All right. What's good with this next one here? Guys, look at the top and bottom. Are they good? 600 up, 600 down, equal sign. Cool. They don't take really, they're not going to affect our net force answer here. So now we got 250 to the what direction? And how much going to the left? So if they're opposite directions, we're going to subtract. So just do 250 minus 75. And that gives us 175. So the net force will be at 175 newtons to the right because the applied force vector was bigger. So okay. Moving on. Top and bottom equal. Is there any other force? There's just this one to the right. So guess what? Super simplistically, yeah, it's just going to be 60 newtons to the right because there's nothing on the left causing it to either get subtracted or there's no additional force on the right to add to it. Okay, well this one, oh, okay, now we got a couple things going on. Remember guys, same direction, what do you do? Add. So what's 120 plus 60? Okay, so yes, we have 180 newtons going to which direction? To the right. We have how much going to the left? 80. All right, and the top and bottom are balanced, so we would do 180 minus 80. Yep, and in which case the F net would equal 100 newtons to the right. And the final, top and bottom, balanced, with the equal sign through them. Yep, because that's the only other force left. That is your F net, 55 newtons to the left. Right? Because the top and bottom are balanced, so this is the only force right now that's left over, is this 55, and it is going to the left, so that would be the full net force. Okay, so now we're going to take what we've dealt with, what we've learned, and kind of go and move from there. All right, so let's take a look at this very first one. If we called it like this, we called it 1, 2, 3, 4, 5, and 6. We're going to look at number 1 first. Okay. So we got top and bottom, they balance out, yeah? All right, excellent. Now, what about, how do I find acceleration? I'm not sure. Well, Newton's second law, net force is equal to mass times acceleration. So if we look at the triangle and cover up A, it's going to be F net divided by M. So I'm going to write that over here. I'm going to write A is equal to F net divided by M. Do I have M? I do. So M is 5. Do I have F net? Not yet. All right, so then, but are all the forces drawn here? So doing what you just did in the sections above. Top and bottom are balanced. What is the F net for this thing?
Subtract.
There you would subtract these two. So 70 minus 20 would be 50 newtons to the right. So if we now know what the net force is and we divide, 50 divided by 5 will be 10 meters per second. And what direction is the acceleration?
Right.
It is to the right. And why? Because acceleration is always in the direction of your net force. Acceleration is always in the direction of the net force. So if you need to like write that down at the top, that'd be good.
Oh, my what?
Let's just write it. So at the top. Acceleration is always in the direction of the net force. So if my net force is to the left, what direction does the acceleration gotta have to be? Left. If the net force is down, what is the acceleration gonna have to be? If the net force is up, acceleration would be okay, and then vice versa. If I said, hey, you're given the acceleration is to the right, what direction does the net force have to be? To the right. So acceleration is always in the direction of the net force and vice versa. All right? And so you can basically replay this, right? Net force is always in the direction of the acceleration. Those little quotations are basically just, I just use that as shorthand, which means all the words like underneath it or above it were the exact same. So F net is always in the direction of the, and then I changed the last one, acceleration. All right. So let's see. Let's try one that's a little more difficult. Let's take a look at number 3. Let's take a look at number 3. I don't know what I'm doing. How do I start this? I don't have mass. I have acceleration, but I don't have mass. So can I find the net force right off the rip? Now with the net force, all right, is mass times acceleration equation. But does it look like all the forces are drawn there? They do look like they're all drawn there, but what don't we have? We don't have mass, so we can't actually get a number right now for Fg or Fn. But from the drawing, these two things are equal. So does that affect my net force? No. So what I would want to do is I'd want to figure out what my net force is. If I have 240 to the right and 80 to the left, we'll subtract, which is good, 160 newtons. What direction? Good, to the right, because 240 is bigger. And that should make sense because look at the acceleration's direction. The acceleration's direction is to the right. So, okay, that makes sense for us. Now, I have net force and I have acceleration. Now I can find m. So if I cover up m would equal F net divided by A. What was F net? 160, and A is 4. So 160 divided by 4, Be 40 kilograms. So the mass now is 40 kilograms. And this is super simple, guys. Once you have mass, all right, so some of the example problems I wrote on the board. Once I know what M is, and we're using G as 10, gravity 10, all you're doing is mass times 10 to get weight. So what's correct? I'm just going to just quickly scribble that in. Fg is equal to mg, so we have 40 times 10. Fg is 400. So we have 400 newtons down, and then our normal force up would also be 400 newtons. Why? Because these two dudes are balanced. Okay. What about, let's take a look at number 5.
How do you get 4?
4 for the mass?
Yeah.
I'm sorry, or no, 4 was the acceleration.
Oh,
Yeah, that was given to us. So this was given. We first had to figure out the net force, and then once we had net force and acceleration, you can just do net force divided by A to get our M. So we had to do, since these two were, even though we didn't have a number for them originally, there's nothing there, they're both kind of blank. We have the equal sign, so we know they're good. So just straight subtraction here, gets net force, and then we have that to put into our equation. Net force divided by the acceleration that was given gave us our mass, and then we just plugged it into the other equations. Okay, now the number 5. This is the last one that we'll do together, and then you guys can work on the remainings. So for this one, let's see. What do you guys want to do first here? You can do one of two different things, but what do you want to do first? Find the balanced ones? Okay, so we're going to find Fg first. The equation for Fg is mass times gravity. We're using 10 for G, so if the mass is 40 and gravity is 10, that gives us 40 times 10, 400 newtons. And from there, that would be, because these things are already drawn as like equal, this thing is also 400. Cool. So, great. Only problem, Mr. Lombardo, is there's no equation given to solve for friction force, F sub F. So how the heck do I do that? So my answer to that would be, do you guys remember last week when we had a drawing that looked like this? And they said this was letter B, and it's 1100 newtons down. What does A need to be in order to make this statement true? The F net is 900 newtons down. What would A have to be in order to make this true? It would have to be 200, because they're telling us the net force, if it's 900 down, that means that this has to be 900 greater than this guy. So you're just subtracting 1100 minus 200. I'm sorry, 1100 minus 900. Whoop. And that would give us 200 newtons. And then you can always just double check. 1100 minus 200 is 900. This is the bigger number, so that is why it's going to get the direction downward. So that's what you guys are essentially doing here. except we don't have the net force yet. So then how the hell can we do that? Well, looking at our equation. Is there an equation with F net in it? Yes, at the top. So if I cover up net force, you see how mass and acceleration are next to each other? You would multiply. So what we're going to do first is find the net force, which is mass times acceleration. Mass is 40, acceleration is 4. 40 times 4 would give us 160 newtons. Now what direction? Remember, direction of acceleration is in the same direction as net force and vice versa. They told us the acceleration is to the, so that means the net force needs to be to the right. And if we know that the net force, guys, is 160 to the right, what would this number have to be in order to make that true? 40. We subtracted. So all I did was do 200 minus 160 and got 40 newtons. So if I just double checked top and bottom balance, so I would be doing 200 minus 40 is 160. And since this was the larger number, that would be the direction of the net force to the right, which matches. So this is fully done and complete. Fully done and complete. So you're going to have a question or two like this on your quiz tomorrow. And the other things will be about, all right, some more stuff on forces and free body diagrams, and Newton's first law, law of inertia, and then kind of a little bit of what we did here with second law. So you guys, I need you guys to make sure you finish these 3. 1, 2, and 3, the ones that are not done yet. Okay, so these are the ones that we did together. You're going to be doing these 3 here. This guy, and this guy. Those 3, okay? If you guys have questions on it, or you're really stuck, then you can come up to me and I can help you go through some of it. But I do want you to try. There's plenty now of example problems to look at, all right, and try to think about it logically. Okay, if you have mass, what can I do with it? If I have acceleration, what can I do with it? If I only have force vectors, what can I do with that? Okay, so on and so forth. So please complete these.